Hello everyone. In this video I'm going to do some applications on oxidation number. Let's get started. Work out the oxidation number of the species in bold in each of the following compounds. Well, we have here K2CrO4. Okay, what we can do here, the first step is to break down the molecule that we have here. We have 2K and 1 Cr and 4 oxygens equal to 0. Why 0? Because there is no charge here. K is in group 1, so it is positive 1. Its oxidation state is positive 1. Cr is what I want to calculate. Then O is negative 2, as we agreed from the previous video. So we will have here positive 2 plus Cr minus 8 is equal to 0. Then Cr will equal to plus 8 minus 2. So Cr is plus 6. Okay, next one, Cl. Cl plus 4 oxygens equal to negative 1. It's a polyatomic ion, so the total oxidation state for it is equal to its charge, so it's negative 1. Cl plus 4 oxygen is negative 2, as we agreed before. So Cl is equal to, of course, this is negative 8, will be plus 8 minus 1, so it's equal to plus 7. Okay, we have here, third one, 2Na plus S plus 3O is equal to 0. We have no charge here, so it is 0. Na is in group 1, so it's plus 1, plus S plus 3, oxygen is negative 2, equal to 0. So we have here plus 2 plus S minus 6 equal to 0. So S is equal to plus 6 minus 2, so it's equal to plus 4. Next, you don't have to panic if you have like something between brackets like that. It's very simple. We have here Mn plus 4Br is equal to negative 2. It's a charge. Mn is equal plus 4. Br is in group 17, so it is negative 1 equal to negative 2. So Mn minus 4 equal to negative 2. So Mn is equal to plus 4 minus 2, so it is plus 2. Next, CO plus 6 water, H2O, equal to plus 3. Have very interesting thing here, which is H2O. H2O is neutral molecule, so it is 0. So CO is equal to plus 3. The oxidation state for cobalt here is plus 3. Next, CO plus 6 H2O plus 2Cl is equal to 0. CO, of course, H2O is neutral, so it's 0. I'll never consider it. Then plus 2, negative 1, because chlorine is group 17, so it's negative 1, so 0. So cobalt is equal to plus 2 in this. We have here more applications. Identify the oxidizing agent and the reducing agent. Okay, we can check here. Zn plus CuSO4 is giving ZnSO4 plus Cu. Zn here is in its pure form, so it's 0. You can return to the previous video to check the rules that we have discussed for assigning the oxidation numbers. Zn in its pure form, so it's 0. We have here Cu and SO4. SO4 is a common group sulfate. SO4 is always negative 2. So it's 2 negative, so its oxidation state is negative 2. So it's negative 2, so copper will be positive 2. Zn and SO4. SO4 is -2, so zinc is +2. Cu in its pure form, so it's 0. Now we can check what has happened to Zn. So we can say directly that Zn has been oxidized. So we can directly say that Zn is the reducing agent. Why? Because it has been oxidized. For copper, copper 2 plus has been reduced, gained electrons, so it has been reduced. So we can say directly that Cu2 positive or CuSO4 is the oxidizing agent. Okay, let's check another example here. FeSO4. SO4 is -2, so Fe is +2. We have here K, +1 in group 1. We have oxygen, -2. Now we can work out the oxidation state for chromium. Why I have to do that? Because chromium is a transition metal, so it has variable oxidation states. So I have to work out the oxidation state for chromium. What I can do now, I can just write 2K plus 2Cr plus 7 oxygens equal to 0. So 2 by +1 plus 2Cr plus 7 by -2 is equal to 0. So Cr is equal to, we have here -14 plus 2, so -12. Go to the other side, will be +12 all over 2. So it will be +6. +6. Have here SO4, -2. Hydrogen is +1. Iron and SO4. Okay, so we can check what's the oxidation state for iron here, because SO4 is -2. Iron could be different here. 2Fe plus 3SO4 is equal to 0. So 2Fe plus 3 by -2 is equal to 0. So Fe is equal to, we have here -6. Go to the other side, it will be +6 over 2, so it will be +3. Iron here is +3. K is +1, group 1, SO4 -2. We have here, we have to work out the oxidation state for chromium here. So it will be 2Cr plus 3SO4 is equal to 0. So C2Cr plus 3 by -2 equal to 0. So Cr is equal to, we have here -6. Go to the other side, it will be +6 over 2. So it's +3. So we have here -2 and +3, hydrogen +1, oxygen -2. Okay, we can check now what has happened here. Iron has changed from +2 to +3. So we can directly say that iron 2 plus ion has been oxidized. Why? Because it lost an electron. What else has changed? We can see that Cr, it was +6, it became +3. So it gained 3 electrons. So it has been reduced. We discussed from a while that the species that has been oxidized is considered to be the reducing agent. So we can directly say that FeSO4 is the reducing agent, or Fe2 plus is the reducing agent, while K2Cr2O7 is the oxidizing agent because it has been reduced.